Hello everyone, welcome to Parthiva Tech. In this video, we will solve the problem of the day question on GeeksForGeeks for 20th February 2023. The problem statement for today is count cyclic paths. This problem is based on dynamic programming and algorithms, and this has been asked in OYO Room's interview question. So let's now open this problem. So let's understand the problem statement clearly first. Here it says, given a triangular pyramid with its vertices marked as O, A, B and C and a number n, the task is to find the number of ways such that a person starting from the origin O initially reaches back to origin in n steps. In single step, a person can go to any of its adjacent vertices. So here it is saying that we have been given a triangular pyramid with its vertices as O, A, B and C, and we have to start from origin, and in n steps that has been given as an input, we have to use those n steps to get back to origin. So we have to find that how many such ways are there. Okay, so for example, here it is said that n is equal to 1. So n is equal to that 1 means from 0 we have to start, and in one step we have to go back to origin only. That means we are starting at origin, and after one step we are going to back to origin. So the output is 0 because the minimum length of a cyclic path is 2. And how it is 2? We have to first go from origin to any of the vertices, any of the vertex, that means 0 to A or 0 B, or sorry, OA, OB and OC, and we have to go back again from CO, BO or AO. So at least the minimum length is 2. So now let's look at the second example. Here it is saying that n is equal to 2. So here the output will be 3. So the three paths are, see, we have to use 2 steps. So, and here in the explanation it is giving that O, A, O. So first it will go from O to A, then again A to O. From second way, O to B, B to O. Third way, O to C, C to O. So we have 3 ways there. That's why the output is 3. So here we will first see that what is the approach we need to solve this problem. So here we have looked for this one for 2-step process. So now here we will first see that what are the steps if we are getting it here. So for n is equal to 2, what we have got? We have got O, A and O. And for through B it is O, B, B and O. For C it is O, C and O. So here we can see, so we are starting with origin. Through any of the vertex we are going back to origin. So here it is a 2-step process. Now if you consider n is equal to 3, when n is equal to 3, here this is n is equal to 2. So from here only we will try to come to one approach, that how we will solve that. So if we are given 3 steps, so that means after 3 steps we have to go back to origin. So what it would be? It would be either from O to A, A to B, B to O. So one step will be O, A, B, O. I hope it is clear. From O to A one step, A to B another step, B to O again 3 steps. So this is one option. Again, if you are again starting with OA, then OA, then from instead of going to B, now we will go to C. So we will go to C, then again we will go to O. Now if we start from OB, that means if I start from O, then first it will be going to B, O, B, Then here from B we have two steps. In one way we can go to A, other way we can go to C. So first take A and next one O. In the next option here it will be O B C O. O B C O. In the next way, that means if we are starting with OC, then OC, then from C we have two options, either to go to A and B, and from either of these steps we can again go back to O, because all the nodes are, all the vertices are connected. So OBAO and OCBO. So here we can see we have got our three, that means six combination, that means 6 ways. 6 ways to reach O if we are using 3 steps in between. For n is equal to 3, we have got 6 ways. So this way only we will form, we will try to come to one solution, saying that if we are not at O, that means not at origin in the previous step, so we need to count all those things, all those ways. So suppose in this one we have reached to O in all these cases. So here we can see in A, that means in the previous step, if you are not going to O in this current one, then the previous step when we were at from O to B, B to A, so how many ways we were not going to O but we were on some other vertices. So we were on vertex A without going to O, it was twice. We were on vertex B without going to O, again we had 2 ways, and we were on vertex C, both of the C, without going to O in the previous step. So we also had these 2 options. So if we add this one, twice we were at A, twice we were at B, twice we were at C, then we will get this 6 output. So this approach we will be following here to come to approach to a solution. So here we can go back to, so here the approach is that we can go back to position position O if we are not at position O in the previous step. See here, after n steps, suppose at any n step, we are following the path O A B C. Suppose we are taking for any reference now. So we have first traveled through O to A to B, B to C. But now we have not considered C to A. That means in one step we have reached C here. So if we have got this and we have count all the ways through which we can reach C, then in next step we have a simple option. Now from C we can directly go to A. Directly go to A or directly go to O. So that's why it is said that we can go back to position O if we are not at position O in the previous step. Okay, so therefore the number of ways to reach origin O in the current step is equal to the number of ways the person is not at origin O in the previous steps. So simply we will add that previous instances where that person was not at O. So if you add all those combination and we are given one extra step, so that extra step would be from that particular vertex to O, and that way we will get our solution. So I hope this is clear. So based on that only, now let's start our coding. I will be explaining each part of the coding as well. So here we will first create some variables, saying long O equal to 0, long A equal to 1, long is defined, so it's not required to write long again. A is equal to 1, B is equal to 1, and C is equal to 1. So initially we are initializing these 4 variables, and what are these 4 variables? This O denote the number of path of length n that end at vertex O. A denotes the number of path of length n, that means n that has been provided, that end at vertex A only. We are not reaching to O, we are at vertex A. B denotes, similarly, the B denotes the number of path of length n that end at vertex B, and C denotes the number of paths of length n that end at vertex C. So we are not reaching to O again. We are at one step behind. That means we are at A is holding the number of ways we can reach A from the previous step without reaching O. So total number it holds. So as here we can see, we will get our output if we are starting at 2, n is equal to 2, because for 1 we do not have any path to go. So for that our for loop will start with A, sorry, with I is equal to 2. So here we'll simply write for I is equal to int I is equal to 2 and I less than, it will go up to n, then we'll increment this counter here each time. We'll define a variable counting saying ways to origin. Okay, so this way we have this variable defined, we are defining this variable, and what will this be? Okay, it's origin, not 0, origin. So it will be A plus B plus C. That means when we are counting the second step, so in the previous step when I was equal to 1, so what was the option we had? We had the option to, when n was 1, we had to go option to go to A, go to B, go to C. So each of 3 steps were there. That's why it has been enabled with A, B and C. O to A, O to B, O to C. When we got another step as I is equal to 2, that means one extra step was given, then we got a path to go back to O, because now we are at A, B and C respectively. So on either of these 3. So when we got another step, that is the second step, then we can say yes, now we can go back either from A to O, B to O or C to O. So that's why when we are at this step is equal to 2, then we will add this one and we will get all the ways there. So here when it will be 3, 1 plus 1 plus 1, it will be 3. That is this answer. Because if we are given only one step, so we can go only up to from O to A, O to B or O to C. When we get another step, that time we can go to A to O back, B to O back and C to O back. So we'll add all those 3, and similarly for next iteration we need to calculate even some more things. So that is the thing which we have discussed, ways to A. That means in how many steps we were able to reach to A, but we couldn't make to origin back. So that again, so for that, if we have to reach to A, so here and we could not make to B, so it was O to C, O to B, O to C and C to A, O to B and B to A, all those things. So we will again add all those steps. Okay, so here it will be O plus B plus C. Similarly, I'll just copy paste it for B and C. So if you have to calculate the number of number of ways to reach B, so it will be A and C. Here it is C. Here it will be B and A. Okay, so this is the thing. But here now once we have found this, then we need to assign it, since all the operations are being done with A, B, C and O, we will assign whatever we have got this, we will assign back to these variables. So O will be equal to ways to origin ways to origin, A will be equal to ways to A, B will be equal to ways to B, C will be equal to ways to C. Ways to C. So here one thing we need to take care, that as and when this number of steps will grow in large number, so at that moment, since to avoid it going it out of the in that range of integer, so what we will do, we will initialize a variable here, int m is equal to 100000007 0000007. So here this value, whatever is we are seeing here, is often used as a prime number in on all the programming context and competitions, because it is large enough to avoid integer overflows error, and it is also a prime number which make it suitable for certain type of mathematical operations. In this code, m will be used as a modulus to ensure that the intermediate result of certain calculation do not become large and cause integer overflow errors. So to avoid all those things, what we'll do, to all these operations, just do a mod of m. Here also in all the steps we will add this mod of m. Here also we'll do the same thing, mod of m. Mod of m. Mod of m. Okay, yeah. So and at last here, where this getting ended, here we will return the number of ways to we have to reach to origin back. So return O. Okay, so O is in long here, so we'll just typecast it to integer. So I hope this step is clear. That means whatever I was trying to do here, that means in each step we are adding the number of ways we reached A, we reached B, and we reached C in the previous step. So if we add that and we are given one extra step, then from each of the steps we can go back to origin. So we are just adding all those three. So from each of these three vertex we can go back to origin if one more step is given. So whatever was there in the previous one, we are just storing it here and we are just adding it. So if I look at this one, so if we the example which we were looking at, this O is equal to 3, this one. So if we are given just 2 steps there, that and we had to reach A. So from O to B, B to A, and O to C, C to A. That means if our destination was O in 2 steps, then then our paths will be O to B, B to A, O to C, C to A. Similarly, if we had the our destination as B in 2 steps, then O to A to B, O to C, C to B. Similarly for C, O to A to C, O to B, B to C. So we are getting two ways for each of these 3 vertex. So if I remove this O at the last of this one, then we have 2 instances where A is ending, 2 instances where B is ending, 2 instances where C is ending. Now to this, if we are giving one extra step, then from each of the step we can go back to 0. So for I step, we will just count the number of steps that was needed, there to reach A, B and C in I minus 1 step. I hope this is very clear. That means whatever I'm trying to explain. Okay. So here I'll just try to explain it again. So here we are saying that I'll just try to explain the entire code. Here the thing is that here we are first initializing O, A, B and C, where O represents the count of path of length 1 that end at a vertex 0, vertex O, sorry. A represents the count of path of length 1 that end at a vertex A. B represents the count of path 1 that end at a vertex B. That means each of these variable that is mentioning the number of ways to number of ways which exited, that means which we have found to reach B, A or C respectively. Similarly, C represents the number of the count of paths of length 1 that end at vertex C. Now we are using one for loop that goes from I to n, and in each iteration the code calculates the count of paths of length I that end at each vertex based on the count of path of length I minus 1 that end at each vertex. For example, to calculate the count of paths of length I at vertex O, the code is adding the count of paths of length I minus 1 that end at a vertex A, B and C. Similarly, to calculate the count of path of length I that end at a vertex A, it is adding here the count of path of length I minus 1 that end at a vertex B, C and O, and same goes for B and C. I hope this is clear whatever I am trying to explain. That means if we are at any step in any number of or any iteration of I, if we have not reached O, so in the next step we can utilize that path to reach O because we are given one extra step. So if at any moment we are at either A, B or C and we have not reached O, then in the next step we can just add one step, that means C to O or B to O or C to O, and we will reach there. So we will add number of ways to reach A, number of ways to reach B, number of ways to reach C, and in the next step we are getting one extra step. So wherever we are, either at A, B or C, we will just go from that particular step to O. So okay, so I'm done with my coding. So now let's try compiling this code. Oh, I think some mistake. Okay, here the capital C. So here we can see we have got our output as 3 because for input as 2 when we have 2 steps, so we are getting output as 3. Now let's try submitting our solution. So here we can see we have got all the test cases covered. So we have solved this problem successfully. Yeah, so that's all in this video. So if you have any doubt, you can add it in the comment section. I'll just try to clarify once more. So yeah, that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.